We have question 1.1.3 here. The question says 1.1.3. The question says x squared plus 2x minus 24 is greater or equal to 0. So now this is not an equation, this is an inequality. So we are required to find the critical values that will determine the boundaries of the interval over which the function will be positive, because greater than or equal to 0 means positive. So we're going to find the critical values here. So we're going to find the critical values. It's when we set the equation equal to 0, okay? X squared plus 2x minus 24 equal to 0. Now, we can solve this by factorization. Because the coefficient of x squared is just 1, what we can do, we will just open a bracket here, write x, close bracket, open bracket, write x, close bracket equal to 0. Now we need to find the values that we're going to place in the bracket here, this place, and that place also. So the values that we're going to place here, there and there. Now, what am I going to do? I'm going to consider the constant term, negative 24. I'll write here negative 24. I'm going to list all the factors of negative 24, preferably in ascending order. They're like 1 and 24, 2 and 12, 3 and 8, 4 and 6. And I cannot continue because it will be a repetition of what I listed already, because it will be 6 and 4. So now I will look at the list of the factors of negative 24. Select that one couple that will make a sum equal to 2. Okay, so let's see. With 1 and 24, we'll never make 2. Regardless of the combination, we can 1 minus 24, 24 minus 1, 1 plus 24, 24 plus 1, we cannot. Neither with 2 and 12, neither with 3 and 8, but 4 and 6, yes, we can get positive 2 if we do negative 4 and positive 6. Okay, you can check negative 4 plus 6 makes negative 2, and of course, negative 4 times positive 6 will make negative 24. Then we can, over here, substitute the values. All that won't matter. You can start putting the positive 6 here and negative 4 there. And this now, remember the property that says if I have A times B equals 0, this implies that A equal to 0 or B equal to 0. Now we can write over here x plus 6 equal to 0 or x minus 4 equal to 0. Then x is equal to negative 6 or x is equal to 4. Then we're going to draw the value of x equal to negative 6 and x equal to 4 are not the solution because we have an inequality over there. They're not the solution of this inequality, but they just determine the boundaries of the interval of this inequality. Now we're going to draw the number line. Okay, I want to draw the number line. Let's draw it somewhere here. I'm going to draw it somewhere there. Then the number line here, I will place in the critical values. Okay, the boundaries of the interval, and then because it's a number line, I must take I want to set in plot the numbers in ascending order. So I cannot put positive 4 here and negative 6 there. No, it must be negative 6 and positive 4 there. Now we have our number line split into 3 intervals, from negative infinite to negative 6, and from negative 6 to 4, and from 4 to positive infinite. You see? So now let's check. If I consider this first interval here, this first interval from negative infinite to negative 6. Okay, I want to select a number in this interval, any number in that interval. Okay, and then check the values of if the function will be greater or equal to 0. Okay, will be greater or equal to 0 means positive or 0. Now I want to set there. Let's take a number like I cannot take a number like -5 because -5 cannot be here. -5 falls in this interval. I will take a number like -7. Remember, in the negative like numbers start from like with a bigger magnitude here, but with a negative sign goes down, and a positive with a smaller magnitude and goes up. If I take a number like -7, I will sub -7 for x, -7 for x. Now check. If I sub -7 there, I will get a negative answer here, -1. There I will get -13. -1 times -13 makes positive 13. So meaning that tells me that over here, in this interval, the solution in this interval here, my function will be positive. Okay, so over here I can write a plus sign to say this part, the inequality is of my function is positive. Now I want to consider this other interval from -6 to 4. Okay, in that part I want to select any number in that interval that will make okay, and then check the sign of my function. But I already know that the sign of the function here will always alternate. Okay, if it starts with a positive, the following will be negative and then positive. If it's negative, it's going to be positive and then negative again. But let's check it anyway. I want to select a number in this interval. Excuse me. I prefer to take 0 because it's quite easier to work with 0. If I sub 0, if I take a number like 0, let's say 0 is there, I'll sub 0 for x and 0 for x. I have 6 times -4, which is negative answer, -24. Therefore, in this interval, the solution will be negative. Regardless of the number you can pick up, you can pick in this interval. Regardless of the number you can pick in this interval, the solution will always be negative. Now, let's look at this other, I wrote 0 here. Let's look at this other interval. Then, from 4 onward to positive infinite. Okay, I want to take a number, pick up a number in that interval. Let's take a number like 5. Okay, I want to take a number like 5 there. If I sub 5 here for x, and then 5 there for x, so I'll get 11 times 1, which is positive number, positive 11. So over there, we already know that here is going to be positive. So we have positive, negative, positive. Therefore, the solution will be x. We can write it like this: x would be lesser than or equal to -6. So because we have a lesser than or equal here, this means -6 is part of the interval. Okay. Or x is greater than or equal to 4. Okay. Here I want to make it bold because to say that 4 is part of the interval. So this is the solution. Okay. Sometimes it can be written like in the set notation. It can be written like x is elements of this boundary from -∞ to -6 union, or let's just say, or x is element of sorry, this must be square bracket because we're talking about lesser than or equal. And then similarly over here also must be square bracket 4 and then to positive infinite. So this is the solution. Okay, thank you.